Find the inverse Laplace transform of the following function. So we have 1 minus 2s over s square plus 4s plus 3. So bottom is square, and looking at the table, so if we can write the bottom is sum of two squares or difference of two squares. Look at these two formula. When we have plus in the middle, we get regular sign. When we have minus, we get sine hyperbolic function. Same thing for cosine. So on the top, if you have s, then it goes to cosine. If you have just constant, it goes to sine. So in this question, we have s as well. So let's write down the bottom as sum of two squares or a difference of two squares. So and s square plus 4s, as we know, if we add half of 4, which is 2 squared 4, then this becomes s plus 2 squared. So we can rewrite this as 1 minus 2s over s squared plus 4s. Half of 4 is 2 squared 4. Then we can write a complete square, but plus 4 is not there, so minus 4 and the remaining plus 3. Now from these three we can rewrite as 1 minus 2s over this is s plus 2 quantity square and minus 4 plus 3, that's negative 1. Okay, at least the bottom is now good. The bottom is s plus 2 square minus 1 square. We can write s minus negative 2 square. So a is like negative 2 and b is 1. Now the top, since we have s, so basically we have to make one of these two, the bottom one minus. So s minus a, that means we have to have s plus 2. So on the top 1 minus, if we factor 2 out, let's say 2, then yes, I want plus 2 anyway, so I want to write plus 2. Now if we distribute this is negative 2s, which is already there, negative 4, 2 times 2 negative 4, but that's not there. So negative 4, to balance that I have to write plus 4. If we distribute, then minus 4 plus 4 cancel, we still have 1 minus 2s over s plus 2 quantity square minus 1 square. Now we can combine 1 and 4, that's 5, and separate into two fractions. So negative 2 s plus 2 over s plus 2 quantity square minus 1, and 1 plus 4, that's plus 5, so plus 5 over s plus 2 quantity square minus 1. So let me rewrite one more line. Negative 2 can be pulled to the front, and that's now s plus 2 over s plus 2 quantity square minus 1. And here now this matches with the previous one, not this, okay, just the number on the top, so more like here. So just b means 1 on the top, and we can write this as plus 5 to the front, 1 over s plus 2 squared minus 1. And then take the inverse Laplace, we get the function as negative 2. For this, now we are using exactly s minus a. This is s minus negative 2 over s minus negative 2 squared minus 1 squared. So that's e raised to a. A is negative 2t cos or cosine hyperbolic bt. B is 1t, is t, plus 5 times this one, like here. So same thing with sine. So e raised to negative 2t sine hyperbolic since 1t t. Alternatively, looks like the bottom, look at the question, original question, the bottom factors. So we can rewrite this fraction as a sum of two simpler fractions using the partial fraction decomposition. So let me show you that as well. Okay, alternative. So let me write this as a sum of two fractions, and I'll come back. We can write the given function as a sum of two fractions because the bottom factors as s plus 1, s plus 3, and using the partial fraction decomposition, the routine calculation, we get a is 3 halves and b is negative 7 halves. So the function, given function, this fraction is a over s plus 1. So I pull the a to the front, 3 halves, 1 over s plus 1. B, pull that to the front, negative 7 halves, 1 over s plus 3. Okay. Then using the table, because this is 1 over s plus a, and we know that when we have e alpha t, the Laplace transform is 1 over s minus alpha. So other way around is s minus alpha e raised to alpha t. So the answer in this case is 3 halves e raised to s minus negative 1. So negative 1t. Okay, minus 7 halves e raised to minus 3t. By the way, what we found here, ft, and here, they look different, but they are algebraically the same. Okay, if you write cosh and sins in terms of exponential functions and simplify, you get this final.